because they don't have anything. All right, so what happens in math class if you have a positive and a neutral? What happens if you have a positive and a neutral? It's going to be positive, okay? So, the overall charge on the nucleus is positive, and the overall charge on the electron cloud is negative. Okay, does that make sense? All right. So, if we have a picture, which is not really drawn correctly, but if you have an atom, and you have a nucleus here, that's going to be positive, and out there will be negative. Does that make sense? Okay. Everybody good so far? All right. Now, from there, why is an atom electrically neutral? Does anybody remember from middle school? Or what about the positive and negatives? Why do they cancel out?
Because they equal 0.
What about them makes them equal 0? We're looking for the amounts. What equals each other?
One's negative, one's positive.
Yeah.
So if you add them, they have the same number. One's negative, one's positive.
Okay, you have the same number of positives and negatives. Okay? The number of protons equal the number of electrons. So the positives and negatives cancel each other out. Okay, so y'all are right when you say they cancel each other out. Now, I'm not going to go into how many positive and negatives there are, because we're going to do that later when we study the chemistry unit and we do the periodic table. But somewhere in middle school, you probably talked about how many protons there were and how many electrons there were. Does anybody remember reading the periodic table and figuring out how many protons there were and how many electrons there were? No. Maybe figuring out how many neutrons there were? Really? Don't all do this. Usually in 8th grade.
We didn't have a science
I didn't have a science teacher.
Okay, those of you who had subs, I'm not talking to y'all. The people who had a real teacher. Y'all didn't do this? Y'all don't remember taking like NA with a 22.99 and an 11 and figuring out how many protons you had, how many electrons you had, how many neutrons you had? Alizé's going, yeah, I remember doing this. The rest of y'all didn't all have subs. You at least remember having done it. I'm not asking you if you remember how to do it, but you remember doing it.
Yeah.
Okay, that's at least something. Okay? When you did that, all I'm saying is the number of protons and the number of electrons are equal. Okay? Because they're equal, they do what to each other? They cancel out. That's the only piece I want you to have of that. As long as you understand that they're equal and they cancel each other out, I could be happy today. Okay? Are you with me on that? Okay? We'll talk about how to get the numbers later. I'm not worried about that today. All right. Now, this you should also have learned in another science class. This is not new. Okay? All right. What do you suppose oppositely charged particles do? Okay, I'm going to give you a hint. Do they attract or do they repel? Opposites do attract. All right. Opposites.
That's where I get that from.
Yes.
Okay.
That's where they get that from. So, using examples of what we just worked with, give me an example of some opposites that will attract. All right, we're not talking magnets. That's the next unit. I'm talking about things we just talked about. Okay, so the name of the particles would be what? Protons and electrons would attract. Protons attract electrons. All right, protons attract electrons because you said protons were positive and electrons were negative. Now, let me say this. Can I put neutrons up there? Why can I not put neutrons up there? They have no charge. Okay? Neutrons cannot be used because they have no charge. They do not attract anybody. Okay? It's like using Logan's magnet over there. They're dead. They don't attract. They don't do anything. They just lay limp on the table. They don't stick to the refrigerator. Just slide right down. Now, what do same charge particles do? They what? They repel. Okay? Things that have the same charge repel. Now, I use repel a lot in this unit and in the next unit. What does the word repel mean? That's right, push away. That's a good way to say it. It means to push away. Okay, repel means to push away. Because I'm going to use that word, you guys need to know what I'm talking about when I say something repels each other. They push away. Now, give me an example of some particles that repel. Electrons and electrons. Okay, because they're negative and they're negative. Now again, who can't be used as an example? Neutrons. Neutrons cannot be used because they're neutral. They don't attract. They don't repel. Does that make sense? Yes? Okay. Does everybody have what they need? Yes? Okay. Okay? Don't need that yet. All right. Let's practice for a minute. Sure. I mean, better at it, but I'm not going to face it. Yes.
It is.
You're not good. I just want you to know.
Cold industries. It's cold there. You got to cook. You might want to bring it tomorrow in case they don't find the heat in the tree. We decided they're waiting on the 70s to get here Wednesday and Thursday.
Well, it's not 78 days. So
No kidding.
What is weird?
It ran as half as bad as it said it would.
Where?
Dude, no, the clouds at Pfeiffer look bad. There's like black clouds. Yeah, we need a thing.
All right. Next, I want you to answer the questions very quickly. I'm not giving you but about 5 minutes to answer all the questions. Now, in questions 1 through 6 at the bottom, I want you to answer with attract, repel, or nothing. And some of the answers in 1 through 6 at the bottom, the answer will be nothing. It's not going to attract or repel on all of the answers. Okay? Logan, can I get one? Okay. Do not do that. All right, find me an answer while I fix my 2 absent equals returning. So I'm still missing Sierra and Janine.
I'll go.
We should. We need to go over.
Okay.
So what? Which one?
We can have that friend.
Oh. So let's say that's a positive charge, okay? So any place you can feel the positive charge. So if you could feel it in this range, that's an electric field. So any place you can feel the charge, okay? So it's easier to explain with a magnet because you guys are familiar with a magnet, all right? Most of us don't play with electricity because we don't want to be shocked, okay? And I'm certainly not going to let y'all do that. But if you had a magnet, most of you are more familiar with that. And we're going to do the same thing, only it'll say a magnetic field instead of an electric field. So if you have a magnet and you bring a piece of metal or another magnet around it, when you get it close to a magnet, what do you start to feel? That you'll start to feel it attracting or repelling, right? Same concept. When you have a positive or a negative and you get close to the electric field, you'll actually start to feel the sizzle of electricity. And that's what it is. It's an area where you feel electric charge. All right, but I'm not about to let any of you do that for fear, A, you'd electrocute yourself, or B, I'd be sued. I have no idea. All right, so magnets and magnetic fields, I will let you play with. But electric fields, no. That is so not happening. All right. Has everybody had a chance to do them all? Yes, no? All right, so if we look at number one. All right, you grab one side of the page with questions.
Atom is, and
What's an atom?
The smallest part.
the smallest part of an element that can exist.
Yeah, smallest part of an element. Now, it has to be, y'all get your hands off there. It can exist alone. Now, if it is not the smallest part of an element, if it's been broken down, what does it become? All right, so what are the subatomic particles we learned about? It becomes a proton or an electron or a neutron if you break it down further. That's why I said it's the smallest part that can exist alone. Because if you break it down further, it's one of the protons, neutrons, or electrons. All right, number 2, protons and what are found in the what? Protons and neutrons are found in the what? They're found in the nucleus. All right, number 3, electrons are found in the electron cloud. Protons and electrons have a basic property called what? Charge. They both have positive or negative charges. They just have a charge. All right, 5's a review question. Force is a push or a pull. And protons and electrons are going to have forces because they can push or pull on things because they're positive and negative. Now, will neutrons have a force? No. Why will neutrons have no force? They don't have a charge. They're neutral. And 6, of course, is on the board. All right, number 1. A and C both have what kind of charge?
Negative.
So what do they do if they're both negative? They who? I heard several people say it right and several people say it wrong. They repel. They're both negative, so they're the same. Same repels. Number 2. B and E do what? Nothing. It's got a positive and a neutral. Positive and neutral do nothing. Now, several of you are just writing while we're answering questions. Now that we've shown you how to do those 2, can you do the remaining 4? All right, take about 60 seconds to do the remaining 4. For those of you who have nothing written down there, now that you know what you're doing. So that would include Damien, Chase, Alexis, people I'm standing around who have nothing on those remaining 4. Do them real quick. You got them over there? Okay. You know how to do them. Write the answer down. Damien, you got them done? If I walk over there? What does C and D do? C and D are what? Are they going to retract, repel, attract, or nothing? C and D are what? One's a positive, one's a negative. What you going to do? Attract, repel, or nothing? Yes, right there. Do the next 2. You want me to have that phone on my desk or my pocket till 1:20? Put it up. All right, everybody got it now? All right, so number 2. C and D are going to do what? Attract. What's 4? A and D going to do? Attract. What is E and F going to do? Nothing. It doesn't matter that they're both neutral. They're still going to do nothing. And then B and D? No. All right, everybody good with that? All right, let's talk a little bit about static electricity, and then we'll be ready to do the lab. Because the lab is, there's 2 labs that go with static electricity. And I'll be honest, if it's this cold in the room tomorrow, the static electricity lab is not going to work very well. We need heat for it to work. All right, so static electricity. What is it? Anybody know?
Electricity.
Okay. Some books like to use the definition, a build-up of charge. All right, so when we, for example, I've got rubber-bottomed shoes on today. So if I go home and I walk on my bedroom carpet, because our bedrooms have carpet on them, all right, and I walk with my rubber shoes on the carpet, okay, I build up electrons on the bottom of my shoes, okay? I built up static electricity. If I throw clothes in the dryer, turn the dryer on, clothes rub up against one another, they build up charge.
Or you are balloon.
Static electricity. If I take a balloon, rub it on my head, walk over there and rub it on Anna Lucia's or Virginia's head, I make static electricity. Now, that's one way to talk about static electricity. Another way to talk about static electricity is to say that it is the transfer of electrons from one object to another. So, I have built up these electrons on my shoes, and I walk over here, and I touch Alexis, and I zap or shock Alexis. We've all done it. We have somehow managed to build up electrons. We touch a doorknob, we touch a friend, and shock them. Okay? That is static electricity. Now, when we get to current later in the week, we're going to talk about the difference in how the electrons move. Static electricity talks about moving electrons from one place to another, and then the electrons do what? They stop. Because static means what? Static means stationary. So, if I transfer my electrons from me to Alexis when I shock her, can she then reach over and touch Chase and shock him? No. That would be current, which we'll talk about later in the week. So if I, stupid me, stuck a fork in an outlet and had electricity running through me, touched Alexis to shock Alexis, Alexis could then shock Chase. Now, none of us are doing that in here. You hear me?
Let's do it.
No, do it, because it's going to shock the snot out of somebody.
No, I've done it.
I'm sure.
I stuck my finger in the light socket.
I believe.
I can't fix stupid people. All right? Now, first of all, as soon as we stick a metal object in our outlets, the ground fault circuit interrupters in the circuit's going to shut down and kick off. It's not going to allow us to leave a metal object in the circuit. It's going to stop. All right? It's a safety feature. So it's not possible at this point in this room for that to happen. However, if we had something else and we were allowed to do that, we could transfer electricity through the rest of us. Now, we're not going to do that either. My point is, when we get to current later in the week, current can continue to flow. Static electricity, however, can what? Not. It can only move from one place to another and it stops. You would have to rebuild up the charge. So if all these extra electrons went to Alexis, she's got to build them up again to then turn around and touch Chase. Yes.
So current charge would like say
It will travel through the water, yes. Now, if the body of water is large enough, the charge will be dispersed over the water to a very small amount so you would not feel it. Now, if the body of water was pretty small, then of course the charge is going to be large compared to the small amount of water. So you're going to feel it like in a bathtub, because it's a small body of water, you're going to feel it's going to be a very large jolt. If it's in a swimming pool, it's a larger body of water, it'll be less of a jolt. If it's in a lake or an ocean, you're not going to feel it at all.
How do people like kill fish
with what?
Like they like shock the water and like fish is like.
they don't.
I have no idea.
They throw bombs.
I have no idea. All right. Now, are y'all done?
Cheating way.
All right, where am I at?
It was the fun in that.
All right, so how does static electricity work? Essentially, one object loses electrons and one object gains electrons. Now, notice when we talked about this, all right, did I say what? It's carbon.
You got some carbon.
No, I might have a pencil over there. I don't use those kind. The only kind I use, I sharpen. All right. Notice that I did not say protons were lost or neutrons were lost. What's the only thing that's moving? Electrons. Okay. Now, secondly, if one object loses and one object gains, the electrons must move from one object to another. Now, I cannot draw, and y'all know this. All right, so let's say that I got some carpet here. It looks like grass. I know. I can't draw. All right, my person's going to look even worse. Oh, wow. Okay, he's got really bad feet. All right, so as he rubs his feet, all right, he gets all these little electrons on his feet. Okay, all those little electrons stick to his shoes. Okay, now all those little electrons on his shoes are going to be lost from the carpet. Okay, so his shoes gain and the carpet loses. Okay, that's essentially how static electricity works. One gains, the other loses. That should be start a second. That was around 12 to 10-ish. I don't necessarily pay attention to them either because we don't get to go.
I'm glad not. Sometimes you have to come back.
I
had second lunch. We had second lunch.
I've only had second lunch once. I don't like it.
I don't like second lunch. I go like first and third.
I don't like third.
First, you get
All right, is everybody happy? All right, so what's the law of conservation of charge? We've done this thing like multiple times. The only thing we've changed is we've covered up this word. What's the law of conservation say? If I cover up that of charge part. We've done this law so many times, and y'all still don't know it.
Should I read this one?
Exactly. All you do is take out that first word. Somebody just said energy cannot be created or destroyed. Take out the word energy and put in that word. Exactly. Charge cannot be created or destroyed. That's right. It is transferred. So if I go back to my example here for just a second, the electrons in the carpet, are we gaining any electrons? No, the electrons that are in the carpet are just moving to where? To the shoes. So all the electrons that we have are already here. They're just moving from one place to another. So when I rub my feet on the floor and I build up static electricity, I'm moving them when I touch Alexis to Alexis. Alexis builds up some electrons. Some of them she's just got. Now, if I don't want static electricity, how do I get rid of it? Anybody know? I can touch someone else. Some of it we just lose. For example, tomorrow, I've already said we're going to have a really hard time in this lab tomorrow. It's cold. What do we have a lot of in the air when it's cold? H2O. There's too much water in the air. The water in the air is going to absorb our electrons almost as fast as we make static electricity tomorrow. Okay? So we're going to struggle to make it because the water is going to absorb the electrons and take them away. Okay? They're going to be transferred to the water, which is going to create huge issues for us. We need the heat. Wonder if I told them I need heat for my lab. All right? If a particle loses an electron, what charge do you have if you lose an electron? Okay? You have a positive charge. Now, most people struggle with this concept. Why do you have a positive charge if you lose an electron? If you lose an electron, you have more protons left. Okay? If you lose electrons, you have more pluses left, more protons. Okay? There are more positives left behind. Okay? So if there are more positives left, you have a positive charge. Logan, sit down. You over there, Jacob, stop talking to Nathaniel. Now, the flip side of that is if you gain an electron. What charge do you have if you gain electrons? You have a negative charge. All right? Why would you have a negative charge if you gain electrons? Because what? Yeah. Now you have more electrons. Okay? You have more electrons. And electrons have a negative charge. Now, what particle is never ever lost? Who never ever gets lost? Neutrons, and who else? Who? Protons. The one I want you to always remember is protons. Protons are never lost. Okay, they're in the nucleus. You cannot lose anything out of the nucleus. I need you three to stay in one place.
I am.
Just set it down. You can throw it away when we do the lab. Okay, which particle is not lost? Protons. Okay, protons never leave. They are always in the nucleus. They cannot be lost or gained. The reason is you changed the element. So a minute ago when Bree said, Miss Wall, I need some lead. All right, first of all, lead's not in pencils. Okay, it's been carbon since the 70s, although we keep saying lead. I don't know why. It's not lead. Because if Bree got pissed at Virginia and turned around and jabbed her with a pencil, she could get lead poisoning and wind up seriously ill or dead. Okay, so we don't have lead in pencils anymore. It's carbon. It's graphite. Okay? Go ahead. Whatever. It's graphite. No lead in pencils. All right. So here's what we need for our lab today. We got to do this page, and then we're ready for the lab. So, in order to create static electricity tomorrow for this lab, there are three ways we're going to create it. All right? All right. The first way that we're going to create it is conduction. And we're going to do a small lab with this part first. All right? So, you remember when we talked about the three types of heat transfer? What were the three types of heat transfer? Okay. Now we're going to talk about the three methods to create charging, to create static electricity. All right. So the first one happens to be the same, but it's the only one that's the same. All right. So the first method to create static electricity tomorrow is called conduction. All right. So what is conduction? Okay. What? I'm listening to Jacob, and I'm like, what did he say? I know, that's what I'm like, what did he say? Okay, hold that thought. Sliding against each other is going to be a different type, so hold that thought for the next type. Okay, so conduction is the transfer of electrons by direct contact, or as y'all said, touching. Now, the only thing I changed in the definition is instead of saying the transfer of heat, I said the transfer of what? I said the transfer of electrons. Because this time, instead of talking about heat, we're talking about electricity. So I subbed out the word heat, and I put in electrons. That's all we changed. It can, yes. Depending on resistance, which we're going to get to later, it could create heat. Okay? The object of this, though, is to create as little amount of heat as possible, otherwise you could cause a fire. Okay? Now, where are we going to see conduction?
Your shoes on the carpet.
Remember, we're creating you could say that, I'll take it. Shoes on the carpet. No, that's not, because that's going to fit better in another one.
Like,
What about blue on your head?
how about like when you get like on the desk and you touch somebody like, ow, you shocked me.
No.
I don't know.
That's an electric socket.
Okay, it's not very smart, but yes.
What about a balloon? An electric chair.
All right, all of you keep saying rubbing. The reason I won't take rubbing is because of the second type. The second type is going to fit there. So all of the examples y'all keep giving me that use the word rubbing, save all those examples for this type after the lab, okay? Because we'll come back to that one. All right, so an object in an electrical outlet is certainly going to be touching, and so that's going to fit there, okay? You got anything else for me?
What about the electric chair?
Well, that's certainly going to fit there.
I can't think of anything else, I guess. It sounds dark.
It does sound a tad dark. I won't argue with that. Well, mine wasn't a whole lot better because I was going to say an umbrella in your hand if you got hit by lightning.
See, there's no good things coming out of this.
No. No, we're not hitting on a whole lot here with some positives. That's for certain. But, you know, electricity generally is not going to be very positive because you're not going to wind up in a good place with electricity if you're holding something or touching something and you get shocked. So, you know, we're sort of doomed with this one. So that's true. All right, that'll work for that. All right, so what do I have next? Anything we need? All right, how does it work? We don't necessarily need, we need these two. All right, we're not going to do the how does it work. What is a conductor? This is a review. We should know this. Other than changing out the word heat. All right, that's an example. What do we need for a definition? Not a conductor. Doesn't create heat.
Insulate. And you just say conductor, insulate. No. It absorbs. That was my answer. It absorbs.
Allows heat.
It
absorbs electrons.
Breeze the closest. Allows electrons to flow through it. Yes. Okay, so instead of saying allow heat to flow through it easily, I changed it to electrons. So when, I think it was William said this, examples of this would be your metals.
Yes, I said that.
Okay? So, but the electrons have to be able to flow through it easily. Now, what would be an insulator?
Rubber.
Yes, that would be an example. That's correct. What do I put for a definition, though?
Oh,
Absorbs heat.
Okay, so it stops, okay, or slows,
Slows.
okay, the flow of electrons through it. All right, and Nathaniel said things like rubber.
Isn't it true you can't get electrocuted in a car because of your tires?
Yes. Now, that doesn't mean it won't shock the car, it won't completely fry the electrical system, but the rubber grounds the car so that you'll be safe in the car, yes. That's correct.
The tires at the bottom and the electricity shoots from the top, so it's kind of like this.
Well, I've never been in a car when it's been struck by lightning, and I don't know anybody who has, but, oh, you have?
On the way to the beach.
I believe
Why are you so happy about it?
because it shocked him.
Is that what's wrong with you?
Yes.
It was funny. All I seen was it just come down.
And yes,
It
and
just hit the roof.
it hit him in the head.
Good.
Right in the brain cells.
Did it mess up the paint or anything? Yeah. Did it mess up the electrical system? Okay. Most people that I've talked to who had lightning hit their car, it messed up the electronics in the car. The radio never worked right again, and most of the other stuff didn't work right inside. It just fried the electronics.
What color was the car that you
Well,
was
that car was a piece of crap anyway. So
Oh, okay. Well, that might have made a difference. This person's car was not a piece of crap. And they never got the electronics to work right.
Like everything.
Yes.
That's screwed.
It would. It would. Now, if it was an older car that had very little electronics on it, then it would probably handle that better.
Like the cars that have push starts, you wouldn't start cars.
No, and that's probably true.
You'd be screwed.
Yeah, William.
All right. Does everybody have what they need? All right. All right, Jacob, come here. Ran out of the lab paper. Logan, go grab me one of those bags on the back table.
hello. Hello.
Dang, why are you smelling so hard?
Hello.
You're good, sweet.
I also seen the hidden like
Bro, dude, like what? Like there's something seriously wrong with it.
we're on the way to
We need to like sit down and like
Like,
get blind with therapist because your life is having you know life choices. We need to look at therapist and like
I mean quad. William, what's your name? Will.
Y'all hear something?
Okay.
We hear something.
You know, it's like where you just put the screw and do like a flashlight.
Get that napkin, you go get it. No.
Breathe. I don't know what I have to say.
Get it.
Homemade thing.
You're wearing socks. You don't wear socks.
Who are you talking about? You don't have socks.
I know. I say she's wearing
What kind of
socks.
socks you wear socks? Why?
Say she wears socks.
Oh, come on, it's cold.
Period.
Cold outside, cuz.
You know, this big.
Would you have your hands all over?
You need help.
But this one.
Don't know. I haven't tried to do this since I hurt my wrist. I
What's wrong on it?
think I can hold it with this one and then pull with my right.
What I do? Nut on it? You say clothes?
Not in the middle of class, no.
I thought you said you put a booty on it. I was gonna say, I could go on somewhere, that's not where anything supposed to go.
All right. Y'all are going to need to do this: a battery, a light, and a wire. All right. Most of the Christmas tree lights, the wires are too short to be able to stretch from one end of the battery to the other. A what? A worksheet? Here. All right. So what you're going to need to do is take a wire, and the wire is going to need to touch one end of the battery. And no, this is not going to shock you. The worst that happens is the wire pokes you. It's not going to shock you. It's to put the wire on positive or negative terminal. Put the light on a positive and negative terminal. All right, and then you're going to need to connect the wires to make sure the light works. Okay, and the battery. Now, make sure that you don't drop the lights on the floor. That's what breaks the light bulbs. All right. Now, we need to make a list of what's in the bag because every year I do this, and every year people lose the parts. And you don't have everything you need. So let's make sure that you know what you need to have in these trusty little bags. All right. So inside each bag, what is in here? There's 10 things, first of all. Let's make sure everybody knows what they have. And if you're missing something, you're going to need to ask me for it. All right, this is what? The battery, the light bulb, and the wire are separate. Those don't count. This is what? This is cork. Okay, so you should have a cork. All right. This is what? I know? It's a wood. It's just a wood stick. Well, I'm sort of counting on the people on the front row to tell me what it looks like. What's this? Styrofoam. That's styrofoam. I can tell you already this one got, no, maybe not. This is a what?
Penny.
It's a penny.
Wait, did the little tool thing come in too?
No, the tool I just used. This is what?
Cardboard. And that's zinc.
Yep.
Paper clip.
All right, I should spell the words right. Cardboard. A paper clip. I don't know what that piece of stretched out metal is.
This is
another
paper
paper. Yes,
clip.
it's a pin. It's a pin.
I don't know what that is.
It's a paper clip. It's another paper clip.
That's trash.
Aluminum foil.
All right. You know, y'all are just standing in the way.
Oh.
All right, the aluminum foil is really, really tiny. If you can't find your aluminum foil because somebody made it this tiny, let me know and I'll get you some more aluminum foil. Because the foil in this one is really small. I didn't write it. Paper clip, aluminum foil. All right. The copper, you see this right here?
Yeah.
The copper, some of you have this, and some of you have a piece of actual copper wire that looks like a stretched out paper clip. So you will have one of the two. Okay?
So copper.
But you have something that is this color, this copper wire. All right. This black thing, anybody know what that is?
Rubber.
That's rubber. This bag actually has everything.
And zinc.
And this itty bitty little thing that gets lost 9 times out of 10 is about this big, and it's zinc. All right. And you should have all 10 things. If you don't, let me know, and I will get it for you. Now, then you need a battery, a bulb, and a wire. When you're finished, try very hard to put all 10 things back in the bag and bring these back here. Put the wire back in the wire bag, the bulb back in the bulb bag, and then the battery bag. Because we will need these when we get to the circuit lab. All right? Got it? All right. Groups of 2.
Girl, me and my class bestie, and we always get over there on time, and we're gonna sit in front of each other so we can hold that chair so we can like really do something. Don't ever touch it. Sorry. Don't ever touch me. You should have took that stool, yeah. Or you can see in front. Just whatever you want. No, you for you serious? You love me. I never. No, I can tell you on my toes, but every time you try to go, I need nails. Okay, see, I'm so nails now. Okay, me and Anna got to work great distracted. Come on, where? Hold on, you need a battery, girl. You know this one. Oh, this is ridiculous. I gotta work with the boys.
Possibly, yes.
Oh.
Why are you sexist? Can you not?
It is gonna have to sit beside each other. You said what?
Are you sexist? Can you not work with a boy? Okay.
I'm like looking at y'all.
Doesn't mean they won't. You're fine.
Missing the zinc.
Alright, let me go in the back and get some zinc, and I'm pretty sure I got coal back there. Let me go grab some.
Well, that's the back there. Oh, right here. Thank you.
I'm getting zinc.
Such a fun. Alright, come get the foil.
I need aluminum foil.
Foil.
And then like my stuff on the car. Thank you.
Alright, who else needs stuff? What you missing, Carol? Copper wire. Alright, we go.
Wait.
Hey, we use this for the.
Copper.
Yeah. What wire do we use for the? How do we use that?
Oh. You didn't get your wireless?
No. What's his name? Jacob.
Yeah.
Jacob.
Yeah.
Can you hand me a wire?
This wall. For like when you test and you put the cord on it, like I'm doing cord, so do this.
So what now?
For like when you test it, like do you put the cord
Thank you.
on it like this and then put this?
No.
Okay.
Hey, guys, look up here so I can show you how you're supposed to do this.
I already got it. I know how to do it. I did my first attempt.
Alright. We know we're doing this? Put your stuff on the battery. Everybody looking? Everybody looking? The objects don't touch the battery. You got the wires hooked to the battery, and the wires touch the object. So put one wire on the object. Can you do that? Oh, God. Alright? Can y'all see this? So, when William is standing, see how he's got one wire on this end and one wire on this end? So the wires are touching the objects. The battery itself has your fingers on the battery. Everybody see that? The wires are on the objects. Breed, you see how we did it?
Let me look up here.
Yeah, I know.
We burned ourselves. We did.
You should not be burning yourself.
It got hot.
You should not get hot.
The cord. We ain't get a cord, girl.
Alright, you need cord?
You said make sure y'all got everything.
Alright, who else is missing something?
Oh, it's in the back.
Y'all have cord? Y'all had the complete set. I gave y'all one of that. Y'all weren't missing anything. Anybody else missing anything?
The one that got hot on the
Alright, so these bags might be short. I'm going to remove these bags. Because I know those bags there are correct. Well, I have, how many bags do I have out that I know are correct? That would be enough for 4th period.
Okay, so this go here, right?
About there.
I'm not taking this.
And this go to the top of here.
No, it's not.
Oh. I'm scared. Oh, and we gonna get our games. Hey. You doing it wrong, Brie. Come here, friend.
That's why we did it.
Okay.
Oh, okay, we get it. Thank you.
Ms. Wall, do you want the wires together or apart?
Where?
Like put it together?
You don't touch the wires together. They have to be apart. Otherwise, the bulb will come on every time. When you touch the object, they can't be together.
This is sad. Blue this one. No, it's light up. Hold up, it is. Hold up now. It was just like it.
After that,
It worked. That's weird.
You have to like this side.
you guys like this. Look, like this. Somehow just like this is the other.
Hey. This is an old one? It's probably an old one. Oh. It was the light is the one that doesn't work.
Yeah, if somebody dropped the lights, they may not work. Maybe stack on the stool.
Hey.
That worked great. Cheater.
Is that easy?
That's you.
Cheater, poke it, eater.
No, that's not gonna work.
Thank you.
I thought zinc was a metal.
No, what?
I thought zinc was a metal.
It is?
It's not working.
Hey, bro, y'all in trouble, bro.
Ain't ready to work.
Alright, so a cork is it? I don't want to say nothing.
I
I guess it's off of what, like, what our dating. Let me ask you, hey, was the penny no free option?
Yes, it was. It was, yes.
It was a yes, not a no.
It's a yes?
Yeah.
No, it's a
Why did you say yes to that question?
Right.
Yes or no?
Well,
I said yes.
Is it
Okay,
no?
works.
I mean,
that penny out of hand.
Like y'all hype.
You around John? It's not lighting up. Y'all are liars. Hold on.
y'all get it?
Yeah. Thanks. Yeah.
Oh my God, you did look.
Do we do the front?
Boy!
What do we put that?
William. What?
Come on now.
Did your big light up?
Come on, y'all.
My thing didn't light up. My thing did.
Come on, y'all.
That's why my thing didn't light up. I have to deform things.
And make your best guess based on what you know.
So how we got
I have to
that one?
deform things.
It's in Power School, and I'm going to show you tomorrow. So if you can get Power School to work, they worked on it this weekend, and today it's just all kinds of glitchy, and they don't want us to enter stuff in Power School today.
All right.
And I just haven't had a chance to staple the, you know how I print what answers you got right and wrong? It's not stapled to the test.
Just
So I'm going to do that tomorrow or this afternoon, so I can give it to you tomorrow to see.
All
But your actual test grades are in Power School.
You can look it up if it's not messing up for you.
If it's not messing up for you, yes, you can look it up.
There's only 105.
I think you'll be pleased.
21.
Yours will be far more.
Oh, yeah. My bad. Bro, I don't know, bro.
What the fuck?
Oh, shit, I was gonna say endo or something. That's really.
Hey, I pressed the
This is about.
Did you see
Boy! You want that? Ooh, the ones in dinosaur movies.
I mean, that thing's so dumb.
Wait, it has wheels. Ready for 300. Get on the track.
Chasing.
Y'all sit down.
That's crazy.
Wait, everyone's trying to cheat. Bro. Literally.
Who's these?
Shut up right now. Shut up right now, both of y'all.
All these out.
What? Because there wasn't enough. We have a positive, we didn't have a motion. To make a positive charge, it gotta be.
You guys should be getting close to done.
Okay, because opposite attract, so.
How long is one?
Because what's connected. So you have to have positive and negatives. So.
But you, I bet you won't say it again, though.
I'm a hot rock. You owe me $100 now. We didn't shake on it though. Nah, see, that's not that. You know, shake. You get the other way. Nah, you make it take your hand better.
I thought you were saying last night. I thought what you were saying last night. Ooh.
Period.
One thing I'll say.
I took out peppers and put them in.
Why you need to get in the bag?
On school.
I have a penny jar, y'all. It's getting full a little bit. I'm so excited. When it gets full all the way to the top, I'm gonna put it in the thing. Can you feel
All right, who am I waiting on?
What?
Oh.
Alright, who am I waiting on? Any other groups? Or is everybody finished? Alright, find your notes. We ought to at least be able to do one more type of charging for tomorrow. No, it's not time to go yet.
No, he's gonna be a ball boy.
You're a ball for potential and it's bad.
Well, you go get the ball.
Hey, William, get the city.
Alright, did I get everybody's lab sheet? Yo, Logan, hush. Everybody's lab sheet, I got them? Alright. So, the next type of charging that we want to talk about for tomorrow that you're going to do is the one you will probably use the most, okay? So tomorrow, the lab we're going to do after we finish our notes at the start of class will probably last the remainder of class, all right? Because it's going to take, best guess, 45 minutes to an hour, and it will frustrate us some. Matter of fact, I need to put in my phone that I need to get balloons today. I got by this last time. Balloons. If I get those. $1.03. 4 o'clock. All right. So.
What time is it?
Where did my notes go?
It looks like it's 1:12. 12:30.
All right. So what was the second type of charging I said we were going to do? Anybody remember?
No.
I pulled it up a second ago. Y'all have a shorter memory span than a flea.
What?
You didn't say it. Friction. You said we're gonna do
All
friction.
right. Nope, that's going to be tomorrow. Yes, it was. Friction.
Yeah.
So what was the key to being friction back when we studied friction? You had to do what to be friction? I heard it over here. You have to rub. Okay? Jacob. No. Jacob. I tried. You can't be quiet over there. All right? Friction has to involve what again? Rubbing. Caleb, I just put Jacob there. Go back to your seat. All right? Rubbing two objects together and electrons are transferred. Now, if we rub our hands together, are electrons going to be transferred? No, probably not. So is rubbing our hands together going to create static electricity? No, remember, we're not talking about creating heat. We're talking about creating static electricity tomorrow. All right, again, are you likely to transfer electrons on that surface? No. So what kind of examples are likely to give us static electricity? Doing what? All right, feet on the carpet. All right. Y'all gave me an example earlier. What?
Trampoline.
A balloon on a head. All right, a trampoline. What are we rubbing on the trampoline? Sure.
You try to jump off. Yeah.
Now, with snowboarding, what part is creating the static electricity, though? Okay, the snowboard on the snow is not going to create static electricity because there's too much moisture. The water is going to absorb all the static electricity, and we'll talk about that tomorrow. That's not going to create static electricity. What do all of us do every single week, or at least I hope we all do? Once a week? I'm worried about y'all. Hey, most of us probably, maybe I'll do it more than once a week. I try to do twice a week because it builds up too much for me on the weekend.
Wash your hair.
I do that every day.
It's like a big Friday.
I wash my hair every Friday.
Okay. Washing my clothes. All right. So where am I going to build up static electricity? In the dryer. Okay. That's right. It's not in the washer because of the water. So what do we do in the dryer to help with static electricity? Not the heat. Think about it. What do we do in the dryer to help with static electricity?
It turns and clothes rub together.
Some of you think it's only for smell. Dryer sheets. Dryer sheets are to reduce static electricity. Okay? If you don't use a dryer sheet or some kind of fabric softener and you pull your clothes out, have you ever noticed that all the shirts are stuck together and you got to peel them apart? Socks are stuck to your clothes? That's static electricity. Okay? And if it's in the wintertime, you hear all of that crackling sound. Now, if it's in the summer or like it's cold in here today, you're not likely to hear a lot of that. But if you use a dryer sheet, 9 times out of 10, when you pull your clothes out, do you have socks stuck to your t-shirts? No, you don't, okay? The dryer sheets absorb the static electricity and all those extra electrons, okay? Now, how does it work? Again, 2 objects, rub, 1 object loses electrons, 1 gains electrons. And that's all I'm going to talk about today. Now, induction, which is the last one, is the one you will think is the coolest tomorrow. The first 2 aren't all that cool, but induction is the one that's the coolest. Unfortunately, tomorrow is also the one that's sometimes the hardest to get to work, particularly if it's this cold in here tomorrow. So some parts of our lab tomorrow will work great. Other parts of it will not work so well if it's this cold, and there's absolutely nothing I can do about it. that we just, it's the luck of the draw.
We'll have to complain.
Is what it is. So,
Well, you messed up, Bruce.
all right. Now, if you have anything that's missing for this quarter already, some of you have missing work. Tomorrow is the only day that I will be here after school tomorrow. I mean, this week. Wednesday, of course, we get out early. Thursday's a parent teacher conference day. You've already had 5 grades. A lab today, 4 grades last week. So if you're missing anything, I'll be here tomorrow.
Miss Wall,
Yes.
is there a point of coming to school Friday? Will we have testing?
We will have something. I'm not sure what. It will not be a test. Could very well be a lab grader or something, but will not be a test. We will not test on electricity until next week.
No, wait, because we got a half day Wednesday, no school.
Thursday.
Thursday, you just got to come back to Friday.
Because the only reason why we got a game that Friday.
That's not free.
I mean, we're doing something in here, but it won't be a test. But it could very well be a grade.
So you only stay up tomorrow and make up stuff?